There's a huge hole on Mars, more than 300 feet wide, and it seems that NASA agrees that it could be an opening into an underground world. Could a mysterious space civilization be hiding in there? Well, experts from NASA think that the hole might lead to a lower layer under the surface of the red planet. You can think of it like a trap door that opens into a basement. Scientists care a lot about holes like this because they might connect to big underground caves. These caves would be hidden from the surface and could be safer places for life to exist. You see, Mars' surface is a rough place. It's freezing cold, extremely dry, and constantly hit by radiation. Meanwhile, underground spaces are different. They're like natural shelters, protecting anything inside. That's what makes them some of the best places to look for signs of life on Mars. Interestingly, NASA is usually very careful when talking about life on other planets. Until now, most researchers have been focusing on tiny life forms like microbes, which might be hiding in frozen oceans on nearby planets and moons. But now, scientists really think this hole could lead to huge underground caves. If that's true, besides looking for signs of life, this spot could become a target for future astronauts, since the caves could turn into great shelters and even a Martian base. The photo with the hole isn't new. It was taken in 2017 by the Mars Reconnaissance Orbiter. In the image, we can see many holes scattered across the ground. The area basically looks like Swiss cheese. Most of the holes have dark, dusty ground under a thin layer of light-colored frozen carbon dioxide, aka dry ice. But one hole stands out from the rest. It's perfectly round, sits in the upper part of the image, and is about 328 feet wide. That's a massive opening. The hole also has a perfectly round crater around it. It's like something punched through the surface and left a ring behind. Scientists think it may have been caused by a meteor impact. Scientists believe Mars was much more like Earth billions of years ago, with better conditions for life. But today, the best chance of finding signs of life is underground. Mars no longer has a strong magnetic field or a thick atmosphere, so its surface is constantly blasted by harmful radiation from space. Underground caves or lava tubes act like natural bunkers, shielding anything inside from that radiation. This makes them the most promising places to search for life. Because of that protection, astronauts might one day find signs of past life there, or even fossils. To hunt for these hidden spaces, NASA brought in experts on underground structures and seismic activity from the U.S. Geological Survey. In 2019, they released a detailed map showing more than 1,000 possible cave entrances scattered all over Mars. There's a catch though. All of this data comes from spacecraft flying about 250 miles above the Martian surface. From that height, scientists can spot holes, but they can't see how deep they go or what's underneath. Some may be true caves, while others could just be shallow dents in the rock. Other missions, including the European Space Agency's Mars Express, have also found signs of ancient lava tubes beneath Mars's long-extinct volcanoes. But what makes this newly released image stand out is that it clearly shows at least one hole that appears to lead into an unknown underground layer. And if current plans come true, the earliest human astronauts could see this massive opening with their own eyes in the 2030s. And maybe they'll also be able to examine another Martian mystery. For more than 50 years, scientists have been puzzled by about 2 million dark streaks spread across the surface of Mars. These black marks look like long stains or shadows running downhill. It's almost like someone spilled ink on the planet. They were first spotted in the 1970s, and for decades, no one could explain what caused them. These marks are called slope streaks. They appear on steep slopes, crater walls, and ridges all over Mars. From far away, they look flat and dark. At first, scientists thought the streaks were caused by melting ice. This could create muddy landslides similar to wet dirt sliding down a hill on Earth. Even today, researchers still believe the streaks come from landslides, but not the kind involving water. New research using data from NASA's Mars Reconnaissance Orbiter shows that most of these streaks are caused by dry landslides. Instead of mud or water, it's loose dust suddenly slipping downhill, more like dry sand pouring off a pile when it gets disturbed. This explains how the streaks can form in Mars's cold, dry environment. One famous example is on Apollinaris Mons. It's an extinct volcano south of Mars's equator. On one side of a ridge, hundreds of streaks run side by side, which makes the surface look like a barcode. These streaks appeared sometime between 2013 and 2017. Scientists figured out a bit later that a nearby meteoroid impact could have triggered them. The impact didn't hit the ridge directly, but the shock shook the ground, and it was enough to send dust downhill. Now, because some streaks appeared after impacts, many scientists thought that meteoroids or Marsquakes were responsible for creating most slope streaks. But a new study shows that this idea is kinda wrong. The study in question looked at about 2.1 million slope streaks. They were photographed by NASA's Mars Reconnaissance Orbiter over a long period, from 2006 to 2024. Scientists have estimated that Mars has around 1.6 million slope streaks in total. But some streaks have been counted more than once because they appear in different image sets. So, after analyzing all this data, researchers have concluded that almost all new streaks form because of wind and dust, not impacts or quakes. Look, seasons change on Mars and winds slowly move dust and sand. When that loose material suddenly slips downhill, it leaves behind a dark streak. It's like brushing dust off a surface and revealing a darker layer underneath. Meteoroid impacts and Marsquakes do create some streaks too, but only in very specific spots. Overall, they play a very small role. Less than 0.1% of new slope streaks are caused by impacts and Marsquakes. The analysis has also shown that slope streaks are not spread evenly across Mars. They're grouped into 5 main regions. In each of these areas, new streaks usually form during times of the year when winds are strongest. There's a key tipping point called the dust movement threshold. Once winds get strong enough to lift and move dust, the loose material on slopes becomes unstable. When that happens, dust can suddenly slide downhill, creating a dark streak. This is similar to how strong winds on Mars can kick up dust and form spinning columns called dust devils. They're like small tornadoes moving across the planet's flat plains. One reason this mystery took so long to solve is that these streaks form when scientists can't easily see them happen. The conditions that create new streaks usually occur around sunrise and sunset. And because this phenomenon happens in low light, no spacecraft has directly watched a streak form in real time. The study also calculated how often new streaks appear. On average, about 0.5 new streaks form each year for every existing streak. And since Mars has around 1.6 million slope streaks, that's roughly 80,000 new streaks forming every year. Most streaks seem to stick around for several decades before they slowly fade away. However, scientists don't yet have enough long-term data to be completely sure. Another cool discovery: even though slope streaks cover less than 0.1% of Mars's surface, they may be one of the biggest sources of dust in the Martian atmosphere. In other words, these small-looking features may play a much larger role than we expected. That's why understanding how slope streaks move dust around Mars is important. Mars's dust affects weather, visibility, and even how much sunlight reaches the ground. That matters a lot for future human colonies, which would need stable conditions to survive and operate safely.
What if Martians came to our planet? What if a Mars rover brought back some unknown organism that began to reproduce and wipe out all life on Earth? Well, we've seen this scenario hundreds of times in movies and read about it in books. But in reality, the situation is the opposite. We are the threat. Humans are the ones that could infect another planet. We are the ones that could become the destroyers of Mars. And to prevent that from happening, countries created an international agreement that forbids us from taking certain actions on our red neighbor in space. It sounds like science fiction, but it's real. This agreement is called the Outer Space Treaty. It was signed in 1967 by the Soviet Union, the United States, and the United Kingdom. The treaty states that no country that signs it can claim sovereignty over any celestial body. It also contains many other important rules, but one of them directly addresses how we should search for extraterrestrial life. Now, there's a possibility that certain regions on Mars could potentially host life. However, according to the Outer Space Treaty, exploring these so-called special regions is prohibited. That sounds strange, doesn't it? Searching for life on Mars is one of the main goals of the entire space industry. So, how can these areas be off-limits? Well, the reason is contamination. When we explore these regions, we might accidentally bring life there. A tiny but extremely resilient microbe or bacterium could hitch a ride on a spacecraft, land on Mars, and begin to reproduce. But scientists are not only afraid that Earth's bacteria will destroy Martian life, there's a possibility that these two types of bacteria will mix, and we will not be able to separate one from the other. But what if it occurs that these bacteria were originally from Earth? Imagine NASA spending billions of dollars collecting samples of Martian soil, where life has been detected. The spacecraft brings these samples back to Earth. Scientists analyze them and suddenly realize that these Martian bacteria are actually ours. They had arrived on Mars 10 years earlier, when a robotic rover was simply taking pictures of the Martian landscape. Here on Earth, we already know bacteria that can survive extreme pressure, incredibly low and high temperatures, and even the complete absence of oxygen. For such organisms, adapting to Mars conditions might not be that difficult. But what if they change in that environment? What if they mutate and take on new forms? Scientists might believe they've discovered true alien life, when in reality, it's just Earth microbes that evolved on Mars. There's also a chance that Martian microorganisms could mix with Earth bacteria, making it impossible to separate them. In short, exploring places where life might exist could create massive scientific confusion. And what if contaminating Mars with Earth's life causes it to spread rapidly? What forms would that life take under conditions completely different from Earth's? Mars and the Moon can be explored, but it must be done with extreme caution to avoid biological pollution. And don't worry, the Outer Space Treaty also requires us to be careful not to bring potentially harmful Martian life back to Earth. So, what exactly are these special regions on Mars? Well, they're places where conditions might allow microorganisms to survive, which are warm and wet spots. But here's the ironic part. We currently don't know locations on Mars that meet these criteria. But if there are such places, we can't reach them. So in practice, this law about special regions hasn't really been tested yet. However, scientists also talk about uncertain regions. These are areas that could potentially be classified as special regions after further study. One example is recurring slope lineae, or RSL. These are dark, narrow streaks that appear seasonally on Martian slopes. At first, scientists believed these streaks were signs of liquid water. Later studies showed that RSL are formed by dry granular flows. So, does that mean there's no chance of finding life on Mars anytime soon? Perhaps. But what about all those headlines claiming that water was found on Mars? Couldn't that mean life exists there? Yes, scientists have discovered water, and it's not just small amounts, but entire oceans. The problem is that this water is buried 7 to 12 miles beneath the Martian surface. For comparison, the deepest hole ever drilled on Earth, the Kola Super Deep Borehole, is about 7.5 miles deep. We couldn't drill deeper on our own planet. Now imagine how much time, money, energy, and technology would be required to make a giant pit on Mars. For now, such a mission sounds more like sci-fi than reality. But let's say we do find a microbe on Mars and bring it back to Earth. What kind of danger could such a tiny organism pose? Well, science fiction thrillers give us dramatic answers, but there's also a real-world example. Take the fungus known as chytrid. This microscopic organism reduced populations of frogs, salamanders, and other amphibians across the globe. And this biological disaster affected humans as well. Chytrid is not an alien organism, but its story perfectly illustrates what can happen after even a small biological contamination. When chytrid infects a frog, it causes a severe disease. The fungus attacks the animal's skin, disrupting its ability to regulate water and electrolytes. Electrolytes are salts and minerals essential for biological functions. When this system breaks, it leads to heart failure. The frog doesn't survive, and the fungus continues to multiply and infect other creatures. The outbreak was first detected in northwestern Costa Rica in the early 1980s. From there, it spread south and east, reaching Panama in the 2000s. More recent research suggests that chytrid originated in East Asia and spread worldwide through the pet trade. How it evolved the ability to devastate amphibians is a story for another video. For now, let's focus on the consequences that still affect us even today. Over several decades, the chytrid epidemic caused massive declines in amphibian populations worldwide. Around 90 species disappeared entirely. The impact was especially severe in Costa Rica and Panama. As amphibian numbers dropped, so did the populations of predators that fed on frogs and salamanders. But that wasn't the main problem. Remember what frogs like to eat. They catch mosquitoes and various bugs. So after the fungus pandemic, the insect population increased dramatically. Now think about what is dangerous about mosquitoes. Yes, they bite and leave an itchy mark on your skin. But some species carry dangerous infections, such as malaria. As frog populations decreased, malaria cases among humans increased. Studies showed that infection rates began rising about a year after amphibian decline started. Over the next 3 years, the number of malaria cases rose, but then stabilized. About 8 years after the chytrid outbreak began, malaria rates started to decline and eventually returned to previous levels. Does that mean frog populations recovered? Unfortunately, no. Amphibians are still struggling. It's possible that humans simply took stronger preventative measures against malaria, or perhaps other animals began feeding on mosquitoes. Either way, the ecosystem never fully returned to its original balance. This is the core problem with biological contamination. Damaging one species disrupts an entire system. Like a chain reaction, problems spread from one link to the next. If a simple fungus managed to affect life on Earth where humans can fight epidemics, imagine what a microbe could do on Mars. Even if life exists there, a single Earth organism could wipe it out completely. The reverse is also true. A Martian microbe could cause serious problems on Earth. Imagine a spacecraft returning from Mars and landing in the ocean. A Martian microbe jumps into the water and attaches itself to a shark. The shark begins to change into something terrifying and starts attacking other sea creatures. Fish become more aggressive and begin attacking anything that moves in the water. Mars's bacteria is multiplying. The fish becomes unsuitable for food. Fishing industry suffers losses, and many people begin to experience hunger without fish. Marine mammals disappear, and things get worse and worse. Okay, let's not be so dramatic, but you get the idea. Now it seems there's new solid evidence that Mars once had rainforests, real rainfall, and long-lasting rivers. NASA's Perseverance rover found a mineral called kaolinite on the floor of Jezero crater. Down on Earth, this stuff only forms in warm, wet places with heavy rain that lasts for millions of years. And this kind of rain feeds jungles, not deserts. That means Mars had showers for a long time. And that changes everything we thought we knew about the planet. So that mysterious kaolinite doesn't form from a quick flood or a melting glacier. It forms when liquid water keeps soaking into rock over insanely long periods, breaking it down grain by grain. When Perseverance spotted kaolinite pebbles and boulders scattered across Mars, scientists realized Mars once behaved less like Antarctica and more like the Amazon. That tells us that ancient Mars had a stable climate, thick enough for atmosphere, and a functioning water cycle with clouds, rain, and runoff. The place where the kaolinite showed up, Jezero crater, is pretty cool itself. It used to be a massive lake, fed by rivers that carved channels you can still see today from orbit. Scientists think those rivers could have washed the kaolinite into the crater like a conveyor belt of rainforest soil. Another theory is that a meteor impact blasted the material out of nearby terrain and dropped it there like cosmic shrapnel. Either way, water clearly moved these rocks around, and moving water is a huge deal because stagnant water doesn't shape landscapes like that. Every form of life we know depends on liquid water. Not ice, not vapor, liquid water that sticks around. A warm, wet Mars with rainfall would have had streams, wetlands, and chemical reactions happening non-stop, which are the same ingredients Earth used to kickstart life. Now, this doesn't mean Mars definitely had some creatures waving at the sky, but the planet checked way more boxes for habitability than we ever expected it to. For decades, Mars looked like a planet that maybe thawed for 5 minutes and then froze forever. Now it looks more like a world that stayed comfortable for hundreds of millions of years before everything went wrong. Scientists think Mars lost its atmosphere because it lacked a strong magnetic field, which is like a shield that protects planets from the solar wind, a constant blast of charged particles from the sun that can strip a planet bare over time. While all that rainforest talk grabs headlines, Mars keeps stacking surprises. In 2025, scientists spotted skylights on Mars. Those are giant holes in the surface of the red planet that drop straight down into underground cave systems, which formed long ago. On Earth, caves like this protect life from radiation, temperature swings, and surface chaos, which makes them perfect hiding spots if ancient Martian life ever existed. Some of these caves might be karstic, which means slightly acidic water slowly dissolved the rock, carving out underground chambers over time. That process needs liquid water and patience, which Mars apparently had plenty of back in the day. Scientists suspect these caves could trap ice, preserve chemical fingerprints of life, or even lock away organic material untouched for billions of years, like a time capsule no one has opened yet. The caves sit in a region called Hebrus Vallis, tucked between an old volcano and a massive plain in Mars's northern half. This area doesn't show signs of lava tubes, which scientists already know exist on Mars. Instead, it shows ancient river channels, hydrated minerals, and sediments that only form when water sticks around. Scientists spotted 8 skylights and knew they weren't impact craters because nothing splashed outward when they formed. The surface simply collapsed into empty space below. Researchers pulled this story together using old Mars mission data, including mineral maps, hydrogen readings that hinted at buried water, and ultra-sharp images from orbit. The big deal is this: caves protect things. They block radiation, trap ice, and preserve chemical traces far better than the surface ever could. If Mars ever hosted life, even tiny microbes, those caves rank among the best places to find what's left. Now, a year earlier, in July 2024, the Perseverance rover drove along what used to be a river billions of years old. After the river dried up, part of a rock face broke loose and fell into the channel. Perseverance found it sitting there, untouched for ages. Scientists named it Sheyava Falls. The rock's surface showed tiny dark spots scientists nicknamed poppy seeds, and larger pale blobs with dark rims called leopard spots. When Perseverance zoomed in, it also detected organic molecules. These are carbon-based compounds, the same basic ingredient every living thing on Earth uses. Scientists predicted years ago that if Mars ever hosted microbes, rocks like this one would exist. These spots matter because life needs energy. Some organisms use sunlight, others eat chemistry. Microbes can survive by moving electrons between chemicals, kind of like stealing spare batteries to power themselves. At Sheyava Falls, scientists think microbes could have taken electrons from organic compounds and handed them to iron in the rock. That reaction releases energy that microbes can use to survive. So, Sherlock, the evidence lines up. The dark dots and rims contain a mineral called vivinite, which only forms when iron gains electrons. When iron changes this way, it loses its rusty red color and turns pale. That explains why the centers of the leopard spots look lighter. Perseverance also found another mineral there called greigite. Greigite needs sulfide to form, and microbes can create sulfide by feeding electrons to sulfate, another chemical found in the rock. Now, scientists can't fully analyze this rock yet, but they already have one tool down on Earth, the kind so small you'd miss them unless you knew exactly how to look. If microbes ever lived in Mars's ancient oceans, they probably didn't leave skeletons or bones. They left chemical fingerprints locked inside minerals. On Earth, microbes showed up in oceans about 3.7 billion years ago, give or take. Mars had water around the same time. When water evaporates, it leaves minerals behind, and some of those minerals can trap microorganisms like bugs and amber. On Mars, scientists expect sulfate minerals to play that role. On Earth, gypsum does the same thing. To test this idea, researchers went to a gypsum quarry in Algeria. Millions of years ago, the Mediterranean Sea almost dried up and left thick gypsum layers behind. Those layers preserved ancient bacteria inside them. All this makes the site a perfect Mars stand-in. The team tested a compact device called LIMS, which is an easier way of saying laser ablation ionization mass spectrometer, which I'm only going to say once. A laser zaps a tiny spot on a rock, vaporizes it, and then reads the chemical elements released. Each element leaves a unique signal, like a barcode. That lets scientists spot chemical traces linked to life. When they aimed LIMS at the Algerian gypsum, scientists found thin, thread-like structures already known to be bacteria. They also spotted minerals that microbes help create, like dolomite and certain clays. That matters because microbes don't just leave fossils, they change rocks while they live. Mars makes this harder, though. Its environment differs from Earth's, and any fossils there would be billions of years old, not millions. Scientists also need to rule out non-living processes that could copy these signals. Now, lots of people think that to find all the answers, humans must go to Mars. And the number one goal for the first human mission to Mars is finding life, not digging up resources or setting flags. Scientists want to know if Mars ever hosted living organisms, if it still does today, or if the planet once ran the chemical experiments that led to life. After that, researchers want to understand where Mars keeps its water and carbon dioxide, how those cycles work, and how they changed over time. Geology comes next because rocks keep the planet's memory. Every layer tells part of Mars' story. Scientists need to understand how Mars affects the human body, the brain, and even group dynamics when people live together in isolation. Long-term plans go even farther. Scientists want to learn how plants, microbes, and animals survive on Mars, how radiation alters DNA, and whether reproduction works across generations. They also want to know if Martian microbes could harm astronauts or equipment.
We just found the biggest clue ever that someone lived on Mars. Or should I say, something. Because if you're picturing skinny red extraterrestrials with big goofy eyes, forget it. The Martians we're talking about looked more like this, a tiny microbe. I know, a total bummer, but this could change everything. See that weird pattern on the rock? The one that looks like leopard spots? Experts think it was left behind by ancient life. And no, it's not like someone painted it, the way early humans drew on cave walls. These little marks could actually be leftovers from microbes, signs that some pretty wild chemical reactions were happening back when they were formed. And don't worry, we'll get to that in just a second. So NASA actually found this evidence over a year ago, and they were thrilled, as this was exactly the kind of weird rock they'd been hoping to see on Mars. They thought this weird pattern might be a biosignature, in other words, a clue that life was once there. That could mean an element, a molecule, some substance, or in this case, a funky leopard print pattern on a rock. But scientists were cautious back then. After all, you can't just go around shouting, "We found life on Mars," without being absolutely sure. It could have just been, well, a cool-looking Martian rock, right? So, they studied this sample again and again. And by they, I mean more than 1,000 scientists from NASA and partner institutions all over the world. And recently, they finally came out with a paper that basically says, listen, we can't find another explanation. And that's it. With no other explanation left, this might just be the best evidence we've ever had that something really did live on Mars. The sample, nicknamed Sapphire Canyon, was collected by the Perseverance rover in July 2024. It was taken from rocky cliffs along the edges of the Neretva Vallis River Valley, a region shaped long ago by water that once flowed into Jezero Crater. And we're talking like more than 3 billion years ago. Scientists believe that back then, Neretva Vallis was filled with rushing rivers carrying mud, sand, and gravel into the lake. When the water eventually dried up, it left behind the rocky outcrop where Sapphire Canyon was found. After collecting the sample, the Perseverance rover kept exploring the river valley to get a better idea of the environment where those rocks formed, and to figure out how those leopard spots might have appeared. That step matters because knowing exactly how the spots came to be is key to figuring out if the rock really holds signs of life. In other words, did those patterns form through normal chemical processes that don't need life at all? Or were they actually left behind by microbes? What the rover's instruments found is that the rocks in this area are made of clay and silt, which is exciting, because here on Earth, those materials are great at preserving signs of ancient microbial life. The rocks are also packed with organic carbon, sulfur, oxidized iron, and phosphorus. And you know who loves that stuff? Microbes. Experts think they could have used those ingredients as an energy source, and in the process, left behind the leopard spots we can now see in high-resolution images. Remember when I said these marks might be a microbe's leftovers, right? That's exactly it. Picture you're eating a burger called the Galaxy Burger that has a one-of-a-kind sauce. A drop of that sauce falls on the table. You don't clean it up, and a second later, poof, you disappear. Later, detectives show up trying to figure out if you were there. All they find is that sauce drop you left over. From that, they can tell exactly what you were eating. The Galaxy Burger. But proving you were really there is tricky, since that sauce could have ended up there in lots of other ways. The same goes for the leopard spots. Just by looking at them, scientists can already tell a few things. For example, the pattern shows the presence of 2 iron-rich minerals, vivianite and greigite. On Earth, vivianite often turns up in sediments near decaying organic matter, or in swampy, soggy wetlands. In a similar way, microbes can also produce greigite on our planet. When you find those two together, it looks like they formed through electron transfer reactions between the sediment and organic matter. That could be a fingerprint of microbial life, because microbes use those reactions to get energy and grow. So, going back to our burger comparison, the leopard spots are like the sauce on the table, the leftovers from the process of getting energy. But that's not the only theory. The team also spotted the possible presence of hematite in the rock. And if Mars has the nickname the Red Planet, hematite is the one to blame. It's a heavy mineral that can take on a reddish tone. On Earth, people have been using it as a pigment for paint for thousands of years. Now, scientists think the leopard spots may have formed when chemical reactions with hematite turned parts of the rock from red to white. That process can release iron and phosphate and possibly cause those black rings to appear. And here's the kicker. Those reactions can also provide an energy source for microbes. For now, though, these are just theories. What we can confirm is that those chemical compounds are definitely present in the rocks. But just like in the detective story, finding the sauce drop doesn't prove it came from you. So even though these materials are great for microbes to thrive on, it doesn't automatically mean this is a biosignature. They could have also formed abiotically, or, put simply, without the presence of life. Yeah, it could happen, but for it to happen naturally, without microbes involved, you'd need 2 things: high temperatures and acidic conditions. That's the only way those chemical processes could do their magic and leave behind the leopard spots. And here's the exciting part. Scientists didn't find any sign that these Martian rocks were ever exposed to high heat or acidic conditions. That's why I said they're stumped. They just can't find another explanation. So this has to be a biosignature, right? Well, maybe not. Because there's still a possibility that organic compounds could react even under low temperatures. And maybe, just maybe, we're seeing that happening for the very first time. That's why it's so hard to confirm 100% whether this is the handiwork of ancient microbes or just a natural process. So, in the end, we're still left with more questions than answers. Right now, this precious sample is safely sealed inside a tube millions of miles away on Mars. Hopefully, one day, it'll be brought back to Earth so scientists can study it in labs here. And while we can't confirm it's a biosignature just yet, one thing is certain. This finding by Perseverance is the closest we've ever come to discovering life on Mars. Honestly, just being able to spot a potential biosignature on the red planet is already groundbreaking. Another reason this finding matters has to do with the age of the rock. This evidence comes from some of the youngest sedimentary rocks we've ever studied. Until now, scientists thought that if we ever found signs of ancient life on Mars, they'd most likely be locked inside much older rocks. But so far, nothing has shown up in those ancient formations. Finding a possible biosignature in a young rock suggests two things. First, Mars might have been habitable for longer or later in its history than we ever thought. And second, older rocks might also hold signs of life, but maybe they're just harder to spot. Someday, our technology could be advanced enough to find them. This discovery also makes us think about one of the biggest questions of all, and that is, are we truly alone in the universe, or did we just find the answer? No, not exactly, but it's the closest humanity has ever come to answering that question.
You know, our planet can be absolutely breathtaking if you know where to look. From Greenland's green waves to deserts glowing like molten gold, the planet looks like living art. But there's something even better than knowing what to look for. It's knowing where to look from. For example, from a few hundred miles above the ground, where satellites are, so you can see faces in deserts, hearts in sand, spirals, skulls, and mirror lakes flashing sunlight straight back into space. These are some of the weirdest things you can see from space. In the middle of the Sahara Desert, satellites once caught sight of something meant to scare visitors from outer space. It's a colossal skull staring right up at the sky. Its hollow eye sockets, long nose ridge, and cracked outline looked eerily human, almost as if something enormous had been fossilized beneath the sand. The photo spread quickly online, with people wondering if it could be the remains of an ancient giant, a lost monument, or even evidence of a civilization swallowed by the desert ages ago. But in this case, the truth is climactic. The skull is no fossil or ruin. It's the remains of an ancient volcanic pit carved out by a massive eruption hundreds of thousands of years ago. Over time, relentless desert winds carved away the softer layers of rock, while the tougher ones held firm, leaving behind ridges, pits, and hollows. When sunlight hits it just right, those shadows fall perfectly into place, completing the illusion of a face. Down in the Namib Desert, there's an incredible natural wonder. Fairy circles, roughly circular, bare patches in the grasslands. From above, it looks like a perfect circle cut into the sandy landscape, surrounded by shimmering golden dunes. Some people thought it might be an ancient crater, or even a ritual site hidden by shifting sands. Others guessed it could be the mark of a long-extinct lake, or a meteorite that fell millions of years ago. But the real explanation might be even more fascinating. The formation lies in a region famous for fairy circles, thousands of mysterious round patches scattered across Namibia. For decades, no one knew what caused them. Then, researchers discovered the patterns seemed to emerge naturally, shaped by wind, roots, and even termite colonies competing for scarce water. Over time, these small circles can merge into larger perfect rings, like the ones satellites now call the heart of the desert. The desert is a sight to behold on the ground, but from space, the sheer size of it will make you pause. In the heart of the Canadian Badlands, satellites can see a formation that strikingly resembles a human face, seemingly resting sideways in the soil. This quirky landmark is called the Badlands Guardian by locals. The coincidence is also great. Imagine if you could see a guy wearing a Roman helmet while looking at Italy from space. The contours create what appears to be a forehead, an eye, a nose, and even lips. Some folks amusingly insist that they can see a pair of headphones resting in the ear. For years, people speculated about its origin, pondering whether it was an ancient artifact or a colossal sculpture hidden beneath the surface. However, unless we are proven otherwise, we must believe that the Guardian is actually a natural formation, shaped by the relentless forces of wind and rain over millennia. But the headphones are real. Okay, that's a joke. They're simply a road and an oil well pad, constructed long after nature had woven this artwork. Now, what makes this illusion even cooler is the play of sunlight. Depending on the angle, shadows play around in the gullies and ridges, making the face look almost real. It's an amazing natural effect, a mix of light and erosion. You could say it's our brain's knack for seeing faces everywhere, but come on, just look at it. Near Egypt's Red Sea coast, satellites once revealed something that looked almost too perfect to be natural. A massive spiral design carved into the desert floor. Thousands of sand mounds and depressions arranged in hypnotic precision, stretching wider than a city block. Well, let's speculate. It could be something left after visitors from other planets, or maybe a forgotten symbol from an ancient civilization. Now, theories spread fast. Some said it might be a secret military installation or a message meant for the skies. Others wondered if it was another one of those unexplained desert geoglyphs, like the Nazca lines in Peru. But when artists came forward, the mystery got solved. It's a bit anticlimactic. The spirals turned out to be part of Desert Breath, a massive art installation built back in 1997 by 3 artists who wanted to make something that could only be fully seen from above. Over 1 million square feet of sand were sculpted into smooth cones and hollows, designed to slowly fade away over time as wind reclaimed the land. Ironically, that's exactly why it still fools people today. From orbit, the desert's light and shadows preserve its shape perfectly, making it look brand new every time the sun hits it. It's one of those rare creations where art, time, and nature work together. The pattern is still mesmerizing, and if visitors came from above, they'd be sure to admire it, baffled as we were. Meanwhile, far out on the coastal plains of Peru, satellites revealed something absolutely unbelievable. Etched into the desert are enormous figures. From the ground, you can't see them properly, but from above, they turn into another large-scale art. There's a hummingbird, a monkey, and probably the most famous of them all, a spider. The 8-legged creature is so perfectly drawn, it looks like it's crawling across the earth. The spider alone spans about 150 feet from leg to leg, and what's strange is that it matches a species found deep in the Amazon rainforest hundreds of miles away. So, how could people 2,000 years ago know what it looked like so clearly and carve it into the ground with that kind of precision? Well, theories flooded in. Some claimed the lines were messages to deities watching from the heavens. Others thought they might mark the paths of underground waters or serve as ritual sites to call for rain. But the leading explanation today is both clever and beautiful. The Nazca people scraped away the dark gravel coating the desert to expose lighter soil beneath, creating enormous white outlines that have survived for centuries thanks to the desert's dry, windless climate. The Nazca lines were never meant to be seen from the ground, at least not by wingless humans, but now we have satellites and it's breathtaking. Now, over in China's Gobi Desert, satellites once captured a series of bizarre geometric patterns etched into the sand. Huge grids, bright white lines, and crosshatching that go on for miles. When they first popped up on Google Earth, they went viral. People thought they were looking at gigantic runways, coded symbols, or even the remnants of a lost civilization. Some even speculated they might be a message meant for visitors from space. Well, eventually, experts figured out that those massive lines were actually satellite calibration targets used by China to check the accuracy of their military and remote sensing satellites. Those bright white patterns reflect sunlight really well, helping instruments measure distance, focus, and orientation from way up in orbit. The shapes are really large. Some are over a mile wide and set up in perfect right angles that would impress any perfectionist. They're made for cameras thousands of miles above, not for human eyes. From the ground, they just look like stretches of gravel and stone, but from space, they turn into some of the most precise targets ever created by people. There's more, but that's for some other video. For example, the Eye of the Sahara in Mauritania, a massive 25-mile wide spiral that looks like a portal burned into the desert. Or the boiling Danakil Depression in Ethiopia, glowing in neon golds and greens like it's from another planet entirely. It's kind of cool that you can observe works of art just by zooming in a bit, like it's all just a matter of perspective.
On Mars, nothing is ordinary. That's why a single rock spotted by NASA's Perseverance rover in Jezero Crater has drawn everyone's attention. Its surface is covered with tiny spheres. This texture is both bizarre and weirdly, painfully familiar. Haven't we seen something similar on Earth? Yes, we have. Does it mean there's a mysterious connection between Earth and the Red Planet? NASA's Perseverance rover has been busy exploring Mars, and on August 5, 2025, it spotted something unusual. A rock that looks like it came straight out of a medieval armory. It looks like a knight's helmet forgotten after a battle. Or maybe it's the hat of a witch that crash-landed on the Red Planet. Researchers officially nicknamed the rock Horniflya. It has a dome-shaped top with a pointed tip and a rim that flares out. Its surface is rough and covered with tiny bumps. But the coolest thing is that the rock isn't just lumpy. It's made up almost entirely of little round spheres. Imagine bubble wrap that someone balled up and spray-painted Mars red. Here you go. Geologists aren't too impressed by the rock's shape, but its composition makes them raise their eyebrows. Such little spheres could have formed in a few days. Chemical weathering, volcanic activity, or if rock vaporized by a meteorite cooled down and condensed. On Earth, rocks with similar textures sometimes come from processes involving water, and this is one of the reasons why everyone is so excited now. If underground waters had a hand in shaping the rock, it could mean there was a lot of water on Mars in the past. And water means life. Now, another cool thing about this helmet is that it's a floating rock. The term means that it looks completely different from those around it. Basically, this rock doesn't belong to the area where the rover found it. The best guess is that it was launched from another location. Maybe it was a volcanic eruption, or more likely, an asteroid smacked into the Martian surface and flung it across the landscape. Interestingly, this isn't the first bubble rock Perseverance has seen. Back in March 2025, it found another sphere-covered rock, and some of the tiny balls had holes in them. If you look closely at Horniflya, you can see a bunch of those too. That might mean they're what geologists call ooids, small spherical layered grains. On Earth, ooids form when calcium carbonate builds up layer by layer in shallow water. Picture a warm, shallow sea near the equator. The water is a little choppy and waves are constantly moving things around. That's the kind of place ooids are born. They grow like pearls in oysters. An ooid starts small, usually with a tiny grain of sand or some other speck. The water is overloaded with calcium carbonate, so every time the waves move that grain around, a new layer builds up. Over time, the layers pile on, and you've got yourself a neat little ball. Sometimes the center isn't as tough as the layers surrounding it. That's why the core can dissolve or even disappear completely, leaving behind a hole. If those Martian spheres formed in the same way, this might be the reason why they have those tiny cavities inside them. But there's another possibility. On Earth, the other way of ooid formation is biological. In other words, they sometimes start with the remains of tiny living organisms. Could the ooids on the red planet have formed in the same way? Of course. This doesn't mean we can slap a "Life Found on Mars" headline on it just yet. But the fact that these holes exist is a clue that hints that Mars might have had the right kind of conditions for life. Well, maybe not seashells and oysters, but definitely something worth paying attention to. Weird Earth-like formations aren't the only intriguing things found on Mars. In March 2025, NASA's Perseverance rover spotted something that looked like a bunch of tiny spider eggs. That something was made up of hundreds of little round balls stuck together. It was just sitting there on a hill called Witch Hazel, near the edge of Jezero crater. On closer inspection, it turned out to be a weirdly shaped rock with a bit of red Martian dust on it. Yeah, sadly, or luckily, those weren't Martian spider eggs. Even so, the formation really stood out from everything else around it. The Perseverance team named the weird rock St. Paul's Bay. It's a floating rock too, just like Horniflya. Something once moved this rock from its original spot. One theory claims that it could have been created when a meteorite smashed into Mars. The powerful impact must have blasted rocks into the air. Then, those bits could have cooled down and formed those tiny balls. If that's true, the rock might have come from really far away. Another cool find occurred in April 2023 when NASA's Curiosity rover took a little break from searching for signs of ancient water on Mars and stumbled upon a travel book. Later, scientists figured out that it wasn't really a book, just a rock, but it does look like a little hardcover with a page frozen mid-turn. This book rock is tiny, measuring only about 1 inch wide. In February 2022, the Curiosity rover spotted something that could only be described as a tiny flower made of minerals. It looked like little coral branches, but it was actually a mineral deposit. Pretty rare to see in a flower-like shape. Most of these kinds of deposits form when ancient water mixes with rocks on the Martian surface, so they're not exactly new to scientists. But that one was unique, since it looked like a tiny plant or flower. In January 2023, the University of Arizona shared another bizarre image, a rock formation on Mars that looked like the face of a giant teddy bear. It had two distinct beady eyes, a button nose, and an upturned mouth. It was captured by NASA's Mars Reconnaissance Orbiter, which was orbiting the red planet at the time. Scientists from the University of Arizona explained that the teddy bear face was likely just a natural formation, like a broken up hill or mound in the center of an ancient crater. But let's get back to Horniflya. Perseverance snapped that strange bumpy rock photo during its 234th week on Mars, and NASA even picked it as the rover's best shot of the week. Of course, the rover's main job isn't collecting cool-looking rocks. Perseverance was launched on July 30th, 2020 with a big goal: to search for traces of ancient microbial life and figure out if Mars was ever truly habitable. That mission is connected directly to NASA's Artemis program. It's focused on setting up a long-term base on the Moon. The idea is that such colonies on Earth's natural satellite will help manage and support the first astronaut landing on Mars. At the same time, SpaceX CEO Elon Musk has his own ideas. He wants to send uncrewed missions to Mars as soon as the end of 2026. In the meantime, Perseverance has been busy. Its first assignment was exploring Jezero crater, a site chosen because it once held water. After 3 years of work, the rover wrapped up its full survey of the crater. It happened in December 2024. NASA explained why this mattered. If Mars really went through long wet periods, Jezero's lake beds or shorelines could be some of the best places to look for fossilized signs of past life. Perseverance isn't alone either. 4 other rovers have reached Mars over the years. The very first, Sojourner, landed in July 1997. Then came Opportunity, which was expected to last just 3 months, but ended up operating for an incredible 15 years, until 2018. As for the bubbly rocks, scientists want to know more than just what they're made of. They're curious about where those rocks originally formed, and whether they lie in layers that could reveal how different materials build up over time. Studying their unusual makeup could tell researchers a lot about Mars's inner processes and how its environment shaped the planet's surface over billions of years. And maybe we could finally find out if there was life on the red planet. Hey, you know what would be pretty cool? Having a tiny helicopter on Mars that can buzz around and scan the environment from above. Taking pictures and looking for hidden extraterrestrial life on its own. At some point, somebody at NASA said something like this behind closed doors. Then they went and actually did it. Say hello to Ginny, one of the most significant scientific achievements since we first started exploring space. Back in 2020, NASA's Jet Propulsion Laboratory, or JPL, packed a tiny side project onto the Mars mission. It was called Ingenuity, a flying experiment meant to test if powered flight was even possible on another planet. Just proof of concept, a test demo. The real mission was to explore the surface of Mars with the rover called Perseverance. In 2021, this 6-wheeled robotic scientist about the size of a small SUV landed on Mars in a place called Jezero Crater. Scientists believe there was once a lake here about 3.5 billion years ago. That's important because where there's ancient water, there might have been ancient extraterrestrial life. Perseverance is basically a science lab on wheels. It can study rocks, drill into the surface, and stash samples in little sealed tubes for later. These samples are part of a long-term plan. NASA and ESA plan to bring them back to Earth in 2033 for more study. This could finally answer, has life ever existed outside Earth? Maybe samples won't give the definitive answer, but it's our best shot. Suddenly 2033 seems very far away. The rover has other instruments and testing tools that could greatly benefit future exploration of Mars. But the hero of this story is Ginny. They got the idea for this little chopper from drones here on Earth and thought it could fly around and scout for Perseverance. However, actually making it work on Mars sounds almost impossible. The first problem was the atmosphere. Mars has approximately only 1% of Earth's air pressure, which means there's barely anything to push against. On Earth, chopper blades bite into thick air to generate lift. Since there's basically no air on Mars, it's sort of like trying to swim in fog instead of water. Then there's gravity. Sure, it's only about 38% of Earth's, which helps a bit, but not nearly enough to offset the lack of air. To fly at all, the device would have to be feather light, with huge blades spinning like crazy, just to grab onto the thin air. Oh, and there's also the cold. At night, temperatures plunge to negative 130 degrees Fahrenheit, which is approximately the same as the coldest night ever recorded in Antarctica. That's enough to damage most electronics, and batteries hate the cold. So Ginny charged up during the day with a tiny solar panel, then used that power to keep warm through the freezing Martian night. Every day, scientists had to hope that their drone worth $80 million wouldn't land under a hill in a shadow, especially since it couldn't be controlled manually. Mars is so far away that signals can take up to 20 minutes to get there. Imagine playing a video game where your character has that kind of delay after you press a button. Ginny had to be fully autonomous. All these technological technicalities, and yet Ginny did not simply fly. What was first planned as a 30-day test trial with 5 flights ended up being a full-fledged support mission that lasted 3 years. So, how did engineers pull it off? First, they had to make Ginny as light as physically possible, only 4 pounds. That's lighter than my house cat, but somehow it still carried 2 cameras, a battery, a flight computer, a radio antenna, and even a heater. Everything had to be trimmed down or miniaturized. Then came the blades, Ginny's most important feature. On Earth, a small helicopter spins its blades between 400 and 500 RPM. But we explained why that wouldn't work on Mars. So, Ginny's 2 rotor blades had to spin 5 times faster, about 2,500 revolutions per minute. Each blade was about 2 feet long, made from carbon fiber. Light as a feather, but tough as nails. And instead of sitting side by side like on a drone, those blades were stacked on top of each other, spinning in opposite directions. That cancels out the twisting force you'd normally get from a single spinning blade. You know how helicopters have that tiny tail rotor in the back? They need that because when their main rotor on top spins to lift the chopper up, it also creates a twisting force called torque. That makes the entire vehicle want to spin in the opposite direction. Without some way to fight that, you'd end up doing donuts in the sky. However, Ginny couldn't have a tail rotor because it would add too much weight, take more power, and make things even more complicated. So, engineers created a workaround with 2 large blades stacked on top of each other, spinning in opposite directions, which prevented the drone from spinning out of control. As for controlling it, Ginny didn't have a full-blown AI, but it wasn't remote-controlled either. NASA uploaded flight plans from Earth, but once the drone took off, it flew itself using onboard sensors and code. Basically, like a really smart autopilot. To stay on course, it watched the ground with a downward-facing camera, kind of like tracking its own shadow as a guide. And finally, the result was seen in April 2021, when Ginny lifted off the Martian ground and hovered in place for just 39 seconds. It rose about 10 feet into the air, hovered a bit, spun around a little, and landed safely back on the red dirt. It was short and simple. One small step for a drone, but a huge one for humanity. For the next 3 years, the team responsible was testing the limits, flying Ginny further and further. From above, Ginny saw more than the rover could. The drone helped map the terrain, spotted risks like loose sand and sharp rocks, and even found shortcuts for perseverance. It even saved the rover, so to speak, when its photos helped the team reroute the vehicle around a tricky dune. Ginny also made snapshots of interesting layered rocks, exactly the kind you'd need when you're searching for ancient life. Basically, once the drone spotted something weird or promising from above, Perseverance would roll over to check it out. And it worked way better than anyone expected. However, in January 2024, Ginny went missing. The drone was supposed to do a short hop, go up, hover, land, easy stuff. But after takeoff, NASA lost contact. For a while, no one knew what had happened, just silence. A few days later, NASA finally got a weak signal and pulled the flight data. Turns out, Ginny flew over a featureless terrain. See, it used its downward-facing camera to track movement, kind of like an optical mouse. No texture below meant nothing to lock onto. Mid-flight, the drone got disoriented, tilted, and during landing, one of its blades clipped the ground. NASA confirmed it. The rotor was damaged. It will never fly again. However, this is not a sad story. Even with broken wings, the robot is still useful. After Flight 72, NASA gave Ginny new software and a new job, staying powered on and quietly collecting daily data, possibly for the next 20 years. In a way, Ginny has gone from scout to ground-based observer. So, what happens next? Well, we wait for 2030 while we make more flying robots. The biggest one on the horizon is Dragonfly, a car-sized rotorcraft scheduled to launch in 2028 and land on Titan, one of Saturn's moons. Titan has a thick atmosphere and low gravity, a dream environment for a flying drone. Dragonfly will hop from one location to another, searching for life in that icy landscape. It's like Ginny's big cousin, but with nuclear power and a whole moon to explore. The Project Ingenuity's success is already inspiring NASA to design better Martian helicopters. Some of them could be equipped with grippers to pick up rock samples, or even join up with rovers for full-on search and collect operations. Thanks to Ginny, what started as a tech demo could one day evolve into a fleet of flying robots crisscrossing the red planet.
Well, here you are. You're the first person to set foot on Mars. And your first mission is to explore a place called Jezero Crater. You're wading through the thick, rust-colored dust when suddenly you trip over something and almost fall. You lean closer to examine the culprit and recoil in horror. A skull is staring back at you. Who did it belong to? An ancient Martian dinosaur? A representative of a long-lost civilization? Now, this isn't a made-up story. That's what NASA's Mars robot called Perseverance would tell you if it could speak and, had consciousness. The rover had indeed found something strange, but it wasn't a real skull. It just looked like one. In reality, those were rocks that seemed to be out of place on the red planet. Right now, Perseverance is exploring the edge of a big, empty bowl-shaped area called Jezero Crater. Scientists think that a long time ago, this crater held a giant lake. Perhaps it was even full of tiny life. Since December 2024, the rover has been rolling down a steep hill called Witch Hazel Hill. It's an important mission because this hill might hold secrets about what Mars's weather and environment were like billions of years ago. Anyway, on April 11, 2025, Perseverance stopped to look at a special spot where two types of rock meet. One was light-colored and the other was dark. And right at that spot, scientists saw a weird-looking rock they later named Skull Hill. It stood out dramatically because it was dark and had a sharp shape. But the creepiest thing? It was full of little holes, a real nightmare for those with trypophobia. So NASA shared this discovery in a blog post. They explained that Skull Hill didn't look like the other rocks nearby. The area where Perseverance found these strange rocks is called Port Anson. Scientists think that many of the rocks there didn't originally form in that spot. They were moved from somewhere else an exceptionally long time ago. But how did they move, or what moved them? Now, don't get your hopes up. It doesn't mean we'll find space neighbors on Mars. These kinds of rocks are called floats. They are likely to have traveled a long way across Mars billions of years ago, back when the planet was much warmer and wetter, with rivers, lakes, and maybe even oceans. As the water dried up and the soft ground around the rocks slowly wore away over time, the tougher rocks stayed behind, sitting on the surface. Now scientists are trying to figure out how the strange holes on Skull Hill were made. One idea is that tiny parts of the rock broke off and wore away over time, leaving behind little pits. Another idea is that Martian winds, which carry dust and tiny rocks, might have slowly scraped the surface, kind of like sandpaper, and created the holes. Skull Hill is dark-colored, and at first, scientists thought it might be a meteorite that had come from space. But when they looked more closely at the chemicals in the rock using Perseverance's supercam, the results didn't match what you would expect from a typical meteorite.
Nope.
So, scientists now think Skull Hill might be a volcanic rock. On both Earth and Mars, dark volcanic rocks get their color from minerals like olivine, pyrozine, and biotite. If Skull Hill is volcanic, it might have come from old lava flows nearby that have broken down over time. Or maybe it was blasted out of the rock during a huge crash, something like an asteroid impact that dug deep into the ground and pulled up volcanic rock from below. What helps scientists in their research is that Perseverance now has some cool tricks that help it figure out what Martian rocks are made of. That's how we can learn where the rocks came from and how they formed. Lately, the rover has been super busy. In just a few months, it has collected samples from 5 rocks, studied 7 rocks very closely, and blasted 83 rocks with its laser to learn about them from a distance. That's the fastest pace of research since the rover landed on Mars 4 years ago. At least that's what NASA's Jet Propulsion Lab says. Usually, it can take months to find just one interesting rock in a crater. But up on the edge of the crater, aka the rim, cool and strange rocks are popping up all the time. Scientists are especially excited about getting these rock samples back to Earth to see if they'll show signs that life ever existed on Mars. But there's a problem. The plan to bring the samples back, called the Mars Sample Return Mission, is really complicated, expensive, and running into delays. So, for now, the samples are staying on Mars, waiting for their ride home. Hey, Uber! There's another rover that is currently working hard to help us get more information about our neighbor. That's Curiosity, and it might have found a clue about what happened to Mars's atmosphere from billions of years ago, thick and carbon dioxide rich. If the red planet once had warm temperatures and flowing water, what are the signs of all the carbon that should have been left behind? Now, normally, a planet like that would have carbonates, minerals made when carbon dioxide reacts with water and rock buried in its soil. But on Mars, very few carbonates have ever been found, which has been a big mystery. Now, scientists might finally have an answer. A new study suggests that iron carbonate, called siderite, may be hidden inside Mars's sulfate-rich rock layers. These layers weren't easy to spot in satellite images from orbit. That might be the reason why carbonates may have gone unnoticed for so long. At one point in the past, Mars's carbon cycle got out of balance. The rocks started pulling in more carbon dioxide than they were releasing. Over time, this may have caused Mars to lose too much CO2 from its atmosphere. It cooled the planet and made it dry and lifeless. The planet might have been still habitable when this happened, but once carbon dioxide started turning into siderite, Mars may have begun getting too cold to support life. The Curiosity rover found these carbon-rich rocks in Gale Crater, an area on Mars that used to be full of water. The rocks also contain a lot of salts, which usually form when water dries up. This supports the idea that Mars went through some huge changes, likely from a planet with a nice climate to the cold, dry world we see today. If scientists find more siderite in other parts of Mars, it could help explain where all that ancient carbon dioxide went. Even better, it would support the idea that Mars was once warm, wet, and maybe even habitable. But that's not the only discovery Curiosity has made. The rover has a set of special instruments called SAM. Now, SAM's job is to study the rocks, dirt, and air on Mars to learn more about the planet. And one of SAM's biggest findings happened when it studied rocks from Gale Crater. SAM found organic molecules. Organic molecules are special because they're made of carbon, and on Earth, carbon is super important for life. Plants, animals, and people are all made from carbon-based molecules. So, finding these molecules on Mars makes scientists wonder if it's another proof that Mars once had life, a long, long time ago. When SAM looked even closer, it found certain patterns in gases like carbon dioxide and methane. These patterns might match what you would expect if tiny ancient life forms were making organic molecules. But there's also another explanation. These molecules might have been made by sunlight reacting with gases in Mars's air. In this case, no life would have been involved at all. On Mars, strong ultraviolet light from the sun can break apart and mix up molecules, creating new ones that eventually land on the ground. So even though scientists don't have a clear answer yet, finding organic molecules is a really big deal. At the very least, it tells us that Mars had the right ingredients for life, even if we don't know yet if life actually existed there. Now, scientists are using SAM and Curiosity's other tools to keep searching for more clues. Mars looks like a silent, barren red desert, but it hides a terrifying threat no astronaut can escape: Martians. Nah, it's worse: dust. It might sound odd at first, but Martian dust is razor-sharp, toxic, and relentless. It's filled with chemicals so dangerous they can destroy not just the technology, but your body from the inside. The dust we breathe on Earth is worn smooth over thousands of years by water and wind, But Mars doesn't have a nice, delightful atmosphere and tons of water like we do. Its dust, called regolith, is angular and cruel, and unfortunately, it doesn't want to stay politely on the ground. It's constantly falling from the sky and covering everything. Every few years, Mars undergoes planet-wide dust storms. They coat landers, vehicles, habitats in a thick, suffocating blanket. NASA's rovers have already been crippled by this invisible threat. Their Opportunity rover, the plucky machine that long outlived its original mission, was finally finished off when dust covered its solar panels. The poor rover couldn't recharge. And eventually, the dust will get into spacesuits. Then astronauts would be in danger, because this regolith is laden with some dangerous stuff. The first is silica, fine, inhalable particles. Once you breathe those in, they can cause an incurable scarring of lung tissue. Next, gypsum, a mineral that, while harmless in small doses, could also cause big respiratory issues when inhaled constantly. One of the most horrifying ones is perchlorates. These are salts that can mess up thyroid glands and create a situation where the body stops producing enough blood cells. And finally, nanophase iron oxides. These are tiny iron particles that can infiltrate the bloodstream, and trust me, that's not going to be pretty either. Martian dust is also exceptionally fine. Individual dust grains are as small as 3 micrometers, which is about the size of a mold spore. For comparison, a human hair is about 30 times thicker. That means it could get in super easily and get deep into the lungs. Once inside the body, the dust isn't easily expelled. There's this sticky mucus in human lungs that serves to keep us safe from stuff like that, designed to trap and expel invaders. But particles smaller than 5 micrometers bypass the lung's natural defenses. You might not even notice anything, while the dust would remain trapped inside you until it eventually enters the bloodstream. You might think we just have to filter it, but regolith is super hard to protect people from. Exposure to it could happen in every imaginable way – through inhalation, contaminated suits and surfaces, eye exposure, which could even lead to blindness, or even accidentally eating contaminated food and water. Sure, astronauts will be shielded inside high-tech suits, but even the best suits won't be perfect. Regolith is small and clings to surfaces even with electrostatic charges and mechanical tenacity. It can sneak into helmet seals and worm its way into ventilation systems. Or, say we build a habitat module, but its air filters could clog during a dust storm. Or the Opportunity situation might repeat. Solar arrays covered with dust and failing just when life support systems need full power. The consequences for human crews could be catastrophic. But hey, luckily, there's good news. NASA is already thinking ahead about this. First, dust filtration will be essential. They want to fill habitats and rovers with high-efficiency air systems, the ones that would trap even the finest of particles. Of course, they'd still clog and would have to be replaced, which means that future missions will have to carry extra filters, enough for years of exposure, or even invent self-cleaning filtration systems. There's also this thing called electrostatic repulsion devices. It's technology that uses electric fields to push dust away from surfaces. This could keep spacesuits, airlocks, and life support modules dust-free. Of course, the strictest protocols must be inside habitats. Poor astronauts would have to do home chores literally every day. Vacuum their suits, scrub floors, replace air filters. Imagine conquering other planets only to end up doing home chores again. What's even worse is that we already have space radiation, which is everywhere above the Earth's atmosphere. It's been a huge headache for decades. Adding Martian dust exposure to the mix would make that problem even worse, not even mentioning freezing nights and the lack of a supportive atmosphere. The grim truth is that there will be no emergency evacuations from Mars. The red planet lies at least 9 months of travel away from Earth. There are also communication delays of up to 22 minutes each way. So, no matter what happens, astronauts will have to be fully self-reliant. The journey to Mars is going to be messy and super complicated. Space isn't a vacation spot. Your muscles waste away in zero gravity. You experience vision loss because the brain pressures against your eyes, your blood changes, and that's just what astronauts on Earth orbit go through. And this isn't the only problem NASA is currently facing. Another one is how to send stuff there in general. You can't ship every brick and sell it to Mars. It's too heavy, too expensive, and too slow. So, our astronauts will have to DIY their way into survival right there on the spot. We'll have to grow food in red dirt, print habitats out of nothing, and engineer microbes that turn carbon dioxide into breathable oxygen. They'll also have to get used to new, weird living conditions. Mars is the fourth planet from the Sun, right after Earth, and it receives less sunlight than we do. Its gravity is about 40% of Earth's, which means when standing there, you'll feel lighter and your bones will weaken faster. 1 year there lasts 687 Earth days. But hey, you get twice the birthdays. And yeah, it's livable. It's just wrapped in an unbreathable carbon dioxide atmosphere, dusted with toxic soils, and baked in unfiltered cosmic radiation. Even water exists, frozen at the poles and buried underground, though no oceans. Space living will be part science fair, part medieval farm, and part sci-fi horror. Some space agencies are talking about terraforming. That means changing Mars to be more Earth-like, thickening its atmosphere, warming its soil, releasing liquid water. Sounds like salvation, but it's actually extremely complicated and dangerous. While there are no little green people to greet us on Mars, there might still be life there, in the forms of bacteria, ancient, slow-moving, tucked deep underground. Mars used to have entire oceans covering its northern hemisphere. Back in the day, it resembled Earth. It might have had a thick atmosphere, rivers slicing through canyons, rain falling from the skies, and lakes shimmering under twin moons. But somewhere, about 3.5 billion years ago, things changed. The water dried out or froze. The planet's atmosphere thinned into a whisper. Now, all we have from this time are ancient signs, the valleys, the deltas, the hints of methane in the air. They remain like a fossil record. All this means that life could have existed on Mars. Not some big animals or human-like species, that's extremely unlikely, but some tiny organisms, and unfortunately, if they were there, we struggle to find them now. Still, some bacteria are extremely persistent. It's possible that we'll find traces of them somewhere on the Martian surface. That would be our first ever living organisms found outside our planet, and proof that extraterrestrial life is possible and not as rare as we thought. But if we start terraforming, we might destroy these ecosystems before we even find them. We could erase Mars's ancient history, its geological wonders, and its right to exist as it is. Do we really have the right to do all that just because we want beachfront property on Valles Marineris? It's the Jurassic Park dilemma all over again. We're so preoccupied with whether we could do that we don't stop to think if we should. Plus, exploring Mars isn't just about discovering life. It's about understanding Earth's future, the nature of life itself, and maybe even finding humanity's second home. We might also discover that we should put more effort into cleaning up our current home. Meanwhile, Mars researchers remain optimistic. They think that with proper planning and equipment, all the dangers are manageable. The road to Mars won't just demand bigger rockets and better suits. It will demand wisdom, and we'll see how the future unfolds.